Alright, this is our video for section 1.3 on distance. So we're going to talk about distance. First thing we want to do is figure out what distance is. Now our definition for distance, it's pretty basic and you probably already know what it is. It's how long a line segment is. Okay, if we took a ruler to it and we measured how long it was on the ruler, that's what we're finding, the distance, how far it is from one point to the other, from one end point to the other. Now there's two ways of using, or two types of problems, two ways of thinking about distance. We're going to look at both. The first way is distance on a number line. So if we look here, we have a number line. Notice that it's only one dimension, or one way. Okay, we can only go left and right. And I'll show you how to solve that in a minute. But a number line just goes left and right, just goes horizontal. Second way is on a coordinate plane. Now on your coordinate plane you have two directions. Okay, two ways. You've got an x-axis and a y-axis. And your x-axis is your horizontal one, just like your number line. You normally would be. And then your y-axis is also a number line, but it's a vertical number line. And they're put together and they make the coordinate plane. Okay? A couple things I want you to know, and you probably already know them about the coordinate plane, but we're gonna go over them anyway. First one is where the origin is, and it is at 0, 0. It's where your x and your y-axis intersect. Now, if you forgot, remember points. You list them out, x first and then the y, so how far left and right you're going, and then how far up and down. And that's a common mistake for people because they get it mixed up with slope. And we'll talk about slope later, but for a coordinate plane, if you're plotting points, you go left and right first and then up and down. Okay? And then there are four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. And they're numbered in that order. You start up here at the top right and you go counterclockwise and you number them. Okay? So that's what I need you to know about the coordinate plane. The x and the y-axis, the origin, and then the four quadrants. Alright, so let's start talking about distance. Distance on a number line. To find distance on a number line, all you need to do is count the spaces between two numbers. Pretty simple, okay? You're just going to count the spaces between two numbers. Where people go wrong on this is they count the lines, okay? So, in any case, if you're confused about it, I would always draw yourself a number line. It's not that difficult, and then just count the spaces. It can't be that bad. So here's our example. What's the distance from -1 to 4? We've already drawn ourselves a number line. We're going to start at -1, and we're going to go to 4. So we go 1, 2, 3, 4, 5. Okay? That's the distance. So we would say D equals 5. Now where people go wrong again is I've marked those 2 points. If for some reason they counted the lines, there's only 4 lines between there. A line at 0, 1, 2, and 3. So then they would say the distance is 4. And that's how people make a mistake. But what I want you to do is count the spaces. Okay? So draw yourself a number line and just count it out. It's not that difficult. The second way, and this one's a little more involved, is distance on a coordinate plane. It's not as easy as just counting, unless you have a vertical or horizontal line. Then you can count, because it's just like on a number line. Otherwise, let's make a note of that. Let's say that vertical / horizontal line, you just count. Okay, there's a hint. You don't need to use this formula I'm going to give you if you have a vertical or a horizontal line, because you could count it just like you could on a number line. In any other case, you need to use the distance formula, and you're going to have to know this. You're going to have to memorize it. So it's D equals the square root of x2 minus x1 plus y2 minus y1. In x2, say x1, y1, and x2, y2 are the points you're finding the distance between. Okay? So we're going to do an example. Really all this is plugging numbers in to the formula. The only thing I want to warn you of is to watch the signs. That can cause people some problems, okay? If you watch the signs, you're pretty careful, it should be pretty easy for you. So, our example here is we need to find the distance between -1, -3, and 5, -7. So I'm going to start with my formula. x2 minus x1. Well, I forgot an important part. We need to square these. That would be a big mistake. Squared plus y2 minus y1 squared. Make sure you have the squared in there. That is a big mistake. That is my mistake, so I apologize for that. Make sure that they are squared. And then our points here, I'm going to go x1, y1, x2, y2. And all we're going to do is plug in our values. So, x2, according to our problem, is 5 minus x1 is -1. This is where I said watch the signs because you have two negatives there. Plus y2 is -7 minus y1 is -3 squared. All of that is still underneath the square root sign. Let's simplify this. Two negatives become a positive, so now it's 5 plus 1, which is 6 squared, plus -7 plus 3 now, which is -4 squared, all still under the square root. 6 squared is 36 plus, another spot where people get stuck, -4 squared is positive 16. Anytime you square a negative, it is positive. And then we add those two together. 36 plus 16, well, that's going to be the square root of 52. So there's our answer, square root of 52. That's all I want you to do. I want you to leave it like that, okay? So, a couple things again to watch out for. Watch out for your signs. Make sure you square it in the formula. That was my mistake, so make sure you get that. And then watch out when you square a negative, because anytime you square a negative, it's going to be positive. Alright, I got a practice problem here for you. You need to find the distance between 6, -2 and 0, -8. So pause the video, work it out, come back and check your answer. Alright, now that you've worked the problem out, let's go ahead and check it. We're going to start with writing our formula again. So x2 minus x1 squared plus y2 minus y1 squared. Label our points, x1, y1, x2, y2. Now we plug in our values. So we've got the square root of x2 is 0 minus x1 is 6 plus y2 is -8 minus y1 is -2. Alright, 0 minus 6 is -6 squared. All of this still under the square root sign. Plus minus 8 plus a negative, minus a negative becomes positive. Plus 2 is minus 6 squared. Minus 6 is 36, again positive 36. Minus 6 a second time is positive 36. We add those together, 36 and 36 is 72. So the distance is the square root of 72. One final warning, people will often tell me that the answer to that problem is regular old 72. Make sure you put it underneath the square root sign. Alright, so those are your distance notes for section 1.3. If you have any questions, be sure to bring them to class next time.